Hello everyone, this is Amit. I welcome you all in the video lecture series of the subject Operation Research. This is our first lecture related to the chapter Assignment Problem. So in this particular lecture we will study about Introduction to the Assignment Problem. So what is assignment problem, that we will discuss. What are the various things that is required to be studied in this particular chapter, that we will study in this chapter. So let us move towards our first point of discussion, Introduction to Assignment Problem. So assignment problem, it is again a special case of a linear programming problem which involves in determining the most efficient assignment of peoples to projects, salesmen to territories, contractors to the bidders, and so on. So this particular assignment problem is a special case of a linear programming problem in which it involves assigning of a people to whether it's a project, whether it's a machine, or allocation or assigning of salesmen to the territories or certain routes, then contractors to the bidders, and so on. So it's a special case. The objective is to assign a number of resources to an equal number of activities, so is to minimize the total cost or maximize the total profit of allocation. So in this particular assignment problem, our main objective will be to assign the resources that are available to equal number of activities, means one-on-one basis, and such that one can minimize the total cost or to maximize the profit. Next, one of the most important characteristics of this particular assignment problem is it's a one-on-one basis. Means suppose there are 5 jobs and there are 5 workers, then the characteristics of this particular problem says that only one person can do the job at one time. Only one job can be assigned to one particular person. So it's a one-on-one basis problem. It's a one-on-one basis problem. Is that and it's a one-on-one basis problem. So if there are 5 machines and there are 5 workers, then only each machine will get only single worker, or each worker will only be assigned with one machine only. So it's called one-on-one basis. So this is an important characteristics of this assignment problem. Next, moving to the next slide. Applications of assignment problem. So there are certain areas where this assignment problem is very useful. For example, it's used for assignment of workers to machine. So if there are a number of machines and there are a number of workers, then with the help of this assignment problem you can do the assignment of workers to particular machine in such a way that your total time of doing the production or total time of machining is reduced. You will get the optimal solution, you will get the optimal assignment by doing the allocation or assignment with the help of assignment problem. So assignment of workers to machines, then assigning salespersons to certain territories or certain routes, best availability, best possible resources that are available, considering all the factors. Assigning or assignment is done of salesperson to the certain territories. Next, clerks to various checkout counters. How to assign the clerks to the counters that are available in the best possible way. So at that time also assignment problem will be helpful to get maximum out of the resources that are available. It's a one-on-one basis problem. Next, in assigning teachers to the classroom, yes, there also it can be used. Then in assigning contracts to bidders. So this is all about the application areas. Next, moving to the next slide. Mathematical model of assignment model. Mathematical model of assignment model. So this is the cost matrix that will be given to the this is in general form. See, you can see there are 1 to n number of persons, there are n number of jobs, Persons are shown in the row 1, 2, 3 up to n in general form. Jobs are shown in column. This is x11, which stands for number of units that can be assigned, x11 in general. So this is a general table. Cij is the cost of performing the jth job by the ith worker. So as we had seen on our first slide in the introduction of assignment problem, we had seen that this assignment problem is based on one-on-one basis. One-on-one basis means, suppose there are 5 jobs and there are 5 persons, then each person will be assigned with only one particular job. So that is called one-on-one basis. So is the cost of performing this jth job by the ith worker. This is a general term we are using. We are showing the general form here. Moving to the next slide. Xij is the number of ith individual assigned to the jth job. Then total cost can be find out by x11, that is number of individuals assigned to the jth job, and C11 stands for the cost of assigning. 11 stands for ij stands for row and column. So this is the total cost. In how you can find out the total cost of doing the assignment. Next, mathematically it can be expressed as the objective function. Here the main objective function is to minimize the total time of machining or cost, or if it's in case of an profit, then our objective will be to maximize the profit, because profit cannot be reduced. So there will be always, every businessman wants to increase their profit. So if it's in case of an maximization case, then our main objective will be to increase profit. But in case of an machining time, then our main objective will be to always to reduce the time of machining. So that is the general form here. Objective function, it is denoted by z. Our objective will be to minimize z, and general form is x11 into c11 plus dash 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 plus xnn into cnn. So this is the general form that we had written. Z is equal to sigma I is equal to 1 raised to n, sigma j is equal to 1 sigma raised to n, Cij Xij. So this will give you the objective function, where Cij is the cost of performing the task, and Xij is the number of individuals assigned to the job. Subject to constraints, Xij is equal to 1 for all I resources availability, and Xij is equal to 1 for all I is equal to activity requirement. Why Xij is equal to 1? Because here it is one-on-one basis. As we had seen in our previous slide, only one task can be taken at a time. One person can take only one job. So that's why it is Xij is equal to 1, and Xij is equal to 0 or 1 for all the activities I to j, for all I to j activities. If the assignment is done, then Xij will be 1, but if there is no assignment available, then Xij will be 0. So it is Xij is equal to 0 or 1. 0 will be when there is no assignment. So at that time Xij will be 0 when you are doing an assignment for all I to j activity. Xij will be 1. So this is all about the general form of the assignment problem. Moving to the next slide. Hungarian's method of solving assignment problem, minimization case. So this Hungarian method is mostly developed for the minimization case only. So Hungarian developed this method for solving the assignment problem. So this method was developed by D. Koning, a Hungarian mathematician, and is therefore known as Hungarian method of assignment problem. So it was developed by D. Koning, a Hungarian mathematician, and based on that this name was given, that is Hungarian's method of assignment problem, which was developed for the minimization case. So in order to use this method, one needs to know all the cost of making all the possible assignments. So there must be availability of costs. One must be knowing the cost of making all the possible assignments to use this method. Then it operates on the principle of reduction matrix or matrix reduction. Each assignment problem has a matrix table associated with it. This just means that by subtracting or adding appropriate number in cost table, we can reduce the problem to a matrix of an opportunity cost. So it operates on the matrix reduction, whether it is requirement of adding some appropriate numbers or subtracting from the table, you will get an opportunity cost table or matrix. Then if we can reduce the matrix to the point where there is one zero element in each and every row and column, it will then be possible to make optimal assignments. So to get the optimal solution for the given assignment problem, one must keep in mind that each and every row and column must have at least one zero, assigned zero in that. Then you can reach the optimal solution to the given transportation problem. Next, assignment algorithm. So this Hungarian methods algorithm will be used to solve the given assignment problem. So let us see the steps, or let us see the algorithm of Hungarian method. Determine the cost table from the given problem. So the problem will be given to you, the data will be given to you, and you need to develop the cost table from the given problem. Sub point in that, if the number of sources is equal to the number of destinations, then go to step 3. But if the number of sources is not equal to number of destinations, then go to step 2. So what is step 2? Let us see. Add dummy source or dummy destination so that cost table becomes a square matrix. The cost entries of the dummy source or dummy destinations are always 0. Yes. So what does it mean to say? Okay, the first thing that one needs to check if you are developing the cost table, the first step is to develop the cost table from the given problem. So once you have developed, now your task will be to identify whether the number of rows and number of columns are equal or not. As you had seen in the transportation problem, we were checking it whether the problem is a balanced problem or unbalanced problem. In that we had checked that the supply and the supply capacity and the demand should be equal. Whereas in this case assignment problem, we will have to check if the number of rows and number of columns are equal or not. And if it is not equal, then accordingly dummy row or dummy column will be added, and all the cost associated with it will be 0, are always 0. So that is our second step. Now moving to the third step. Locate the smallest element in each row of the given cost matrix and subtract the same from each element of the row. So for example, there are 3 rows for the given problem that is on our hand. For example, then identify the smallest element in each row and then subtract the same from each element of the row. Suppose there are 5 elements in row 1, 2, 3, 4 and 5. So from that row, the smallest element one needs to identify, and that is 1. So subtract that 1 from all the other elements, so you will get a new reduced matrix. Then subtract the same from each element of the row. That is our third step. Moving to the fourth step. In the reduced matrix obtained in the third step, which we had obtained by subtracting the smallest element of each row from that particular elements of that row, locate the smallest element of each column and then subtract the same from each element of that column. Each column and each row now have at least 1 0. So now same thing applies for the column. Once you had obtained the reduced matrix according to the step 3, now based on that table you need to identify smallest element in each column and subtract it from all the other elements in that particular column. So you will get another reduced matrix in which now each row and each column will have at least 1 0. So that is our fourth step. Moving to the fifth step. In the modified matrix in step, search for the optimal assignment as follows. So in that, first sub point is examine the rows successively until a row with single zero is found. So we will have to examine each and every row that is there in the problem that is given, and examine in such a way that until a row with a single zero is found. So identify each and every row with single zero. If you find the single zero, then rectangle this row with this square or rectangle and cross off all the other zeros in its column. Continue in this manner until all the rows have been taken care of. So wherever you find a single zero in that particular row, make as a square to that and rectangle this row and cross off other zeros in its column. So continue in this manner until all the rows have been taken care. Next sub point, repeat the procedure for each column of the reduced matrix. So in this A point, all the zeros are crossed off in the rows now. Then same procedure is followed for the column. Next, if the rows or columns has two or more zeros and one cannot be chosen by inspection, then assign arbitrarily any of these zeros and cross off all the zeros of that column. So there may be a case when in some rows or in some columns there may be more than one zeros. So at that time you can arbitrarily assign the assignment to any of the zeros, and rest of the zeros should be crossed out. Repeat A through C and above successively until the chain of assigning or cross ends. Then moving to the sixth step, if the number of assignments is equal to n, the order of the cost matrix and optimum solution is reached. Next step, draw the minimum number of horizontal and vertical lines to cover all the zeros of the reduced matrix. So this is the seventh step. You should draw number of horizontal and vertical lines such that all the zero elements should be covered. Moving to the eighth step, develop the new revised cost matrix as follows. Find the smallest element of the reduced matrix not covered by any of the lines. Subtract this element from all the uncovered elements and add the same to all the elements lying at the intersection of two lines. Now once you have drawn all those horizontal and vertical lines for covering all the zero elements, now out of those uncovered elements identify those smallest element that is uncovered by this horizontal and vertical line and subtract these elements from all the uncovered elements and add the same to all the elements lying at the intersection of two lines. So wherever you find the horizontal and vertical line intersecting at any element, you should add the smallest element that was uncovered at that intersecting point and subtracting from those all the uncovered elements. So again reduced matrix will be available with you. Then again go to step 6 and repeat the procedure until optimal solution is obtained. So this was the algorithm or the steps which is used by Hungarian method to obtain the optimal solution to the given assignment problem. One thing you must keep in mind, okay, to obtain the optimal solution you should have an assigned zero in each and every column. There should be one assignment in each row and in each column. Then and then only you will get the optimal solution to the given assignment problem. There should be an assigned zero or assignment in each row and in each column. There should be only one assignment available. Each row and each column should have it should have only one assignment. In each row and in each column there should be only one assignment to the problem. Then and then only you will reach the optimal solution to the given assignment problem. And this assignment problem is always solved for the square matrix. Square matrix means number of rows and number of columns must be equal. If it is not, then it is an unbalanced problem, and accordingly you will have to add row or column whatever is lacking. So this is all about the assignment problem and the way in which we can obtain the optimal solution. To obtain the optimal solution, each row and each column should have one assignment. Then and then you will reach the optimal solution. So I hope This would have helped you to understand about what is the assignment problem and what is the Hungarian method. Thank you.